Hi everyone, let's solve this very interesting calculus problem. We need to find the value of f of 0 plus f prime of 0 plus the second derivative of f evaluated at 0. And the only thing we know is that the following limit is equal to e to the fifth. So let's start with just filling in x equals 0 in this expression and see what we get. So is equal to e to the f of 0 minus e to the fifth, since sine of x is 0, divided by 0. But we know that if a value in the numerator is not equal to 0 and the denominator goes to 0, then the value of the limit should be plus or minus infinity. Since if you divide by something really small, you get something really big. But we know that our limit is finite. E to the fifth is finite. So we can conclude that the numerator of the fraction, in our case, should be equal to 0. So that's the first reasoning that we can use for solving f of 0. So it follows that e to the f of 0 minus e to the fifth is 0. Otherwise, this would be infinite. And then it follows that f of 0 is equal to 5 by swapping e to the fifth to this side and taking the natural logarithm. So that is our first result. F of 0 is equal to 5. But now notice that we get 0 divided by 0, which is undefined. But we can use L'Hopital's rule, which says that if a numerator and a denominator of a fraction in a limit are both 0, then we can take the derivative of the numerator and the denominator. So that's exactly what we are going to do. So out of L'Hopital, we get that the limit L is equal to the limit from x going to 0. And now we are going to take the derivative of the numerator. So that gives e to the f of x. And then we use the chain rule to get times the derivative of x minus e to the 3 sine of x plus 5 times the derivative of the exponent, which is 3 cosine of x. And in the denominator, we get the product rule, which gives x times the cosine of x plus 1 times the sine of x. And these limits should be the same. So let's just try the same thing as before and fill in 1 to this limit. So then this becomes e to the f of 0 times the derivative of f at 0 minus e to the fifth times 3, since the cosine of 0 is equal to 1. And the denominator becomes 0 plus 0, so 0. And now we can apply the same logic as before. Since our limit is not plus or minus infinity but finite, we can deduce that the numerator should be 0. So we get e to the f of 0, which is e to the fifth, times f prime of 0 minus e to the fifth times 3 is equal to 0, from which we get that f prime of 0 is equal to 3. And that is our second result. So f prime of 0 is equal to 3. But that means that we again get that this is 0 over 0, and we can use L'Hopital's rule again. It will be a little bit more complicated. So let me just write g of x as the numerator of this fraction, which is e to the f of x times f prime of x minus e to the 3 sine of x plus 5 times 3 cosine of x. And now we need to calculate the derivative of g of x. So let's start with the product rule. So then this becomes, we differentiate the first part, e to the f of x times f prime of x, times the second part, so this becomes a squared, plus, and now we copy the first part, times the second derivative of x. And now minus, and we start the brackets, and we do the same. Let's differentiate the first part, e to the 3 sine of x plus 5 times 3 cosine of x times 3 cosine of x. So this becomes 3 squared cosine squared of x plus e to the 3 sine of x plus 5 times the derivative of 3 cosine of x, which is minus 3 sine of x. And let's already evaluate g prime of x at 0. So g prime of x at 0 will become e to the f of 0, which is 5, times f prime of 0 squared, which is 9, plus e to the 5th times the second derivative at 0, minus, and then we get e to the 5th times the cosine of 0 is 1, so this becomes 9. And since we have a factor of sine x, the rest becomes 0. And since these terms cancel, we get that this is e to the 5th times the second derivative at 0. So let's now do the same thing for the denominator and differentiate this function. Let's call that h prime of x. That is equal to x times minus the sine of x plus 1 times the cosine of x plus the derivative of sine of x, which is cosine of x. So h prime of 0 is equal to 1 plus 1, so 2. And let's now use our calculations to find the limit by using L'Hopital again. So, because of L'Hopital, we get that L is equal to the limit from x going to 0 of g prime of x divided by h prime of x, which if we fill in 0, we get g prime of 0 divided by h prime of 0, which is e to the 5th times f double prime of 0 divided by 2. So we don't get 0 divided by 0, which is undetermined. We get a real value, and this is equal to e to the power of 5. But then it follows that f double prime of 0 is equal to 2. And that is our final value that we needed. So f double prime of 0 is equal to 2. So the sum that we wanted is 5 plus 3 plus 2, which is 10. And that is our final answer. If you enjoyed this problem and the solution I provided, don't forget to like and subscribe.